Swayam Prabha. Digital India. Educated India.
Welcome to the 11th lecture in mechanics of materials. The last lecture we saw what equilibrium equations are. In particular, we saw that force equilibrium will reduce to divergence of sigma plus rho b equal to rho a, and the moment equilibrium equation will require the stress tensor to be a symmetric tensor. We also started looking at what strain is. In particular, we saw what is the definition of a stretch ratio. We define the stretch ratio as the current length by its original length for a line element oriented along a direction A. Similarly, we define the linearized strain or the engineering strain as change in length by original length, which was lambda A minus 1, and we showed that if the line element is oriented along the x direction, then the linearized strain or the engineering strain along that direction would be dou u x by dou x, where u of x is the displacement component along the x direction. Okay. Now, let us go ahead and we want to generalize this for any displacement field. We want to find what the linearized strain is or what the stretch ratio is. Okay. But before we can do that, we have to understand certain things. The first thing that we have to understand is how do you define curves, how do you find the arc length of a curve. What is a curve and how do you find arc lengths of a curve. Okay. So, now are all these curves? Yes, all of them are curves. Basically, a curve is a one parameter family of functions. Okay. Basically, this is a straight line, this is some curve, this is a closed curve, this is an arbitrary closed curve. Okay. Now, how do you define a curve? Now, if x, y, z let denote the points on the curve. Okay. Then what happens is x would be written as some function of some variable psi, y would be some function of another function of psi, and z would be some other function of psi. Okay. That is, you can define just one parameter to say what are the coordinates of the points that lie on the curve. Psi is a variable which varies. Here psi can vary from psi 0 less than psi less than or equal to psi 1. So, psi varies from 0 to 1. Let us see how do you represent a straight line with this definition. A straight line is, you know, y equal to mx plus c. So, the coordinates are x comma mx plus c comma some z0 at some yz plane, yx plane along some z equal to constant position. You have this as the coordinates of the curve. Okay. Basically, if you take x, y as this and z as this in some z equal to constant plane, this is z naught, you have this straight line here which is y equal to mx plus c. Okay. Here x will vary between say 0 to 1 or 0 less than x less than or equal to 1. an alternate representation for the same straight line is, I can write it as psi m psi plus c z naught, where 0 less than psi less than or equal to 1. This is what corresponds to this definition here. The same thing I can represent it as cos theta psi sin theta psi z naught plus c, okay, where psi varies again from 0 less than psi less than or equal to 1. Here theta and c are given constants. What I have done here, I know that m is tan theta, so I have replaced x with psi sin theta, sorry, psi cos theta, and y as psi sin theta. Okay. So, that is what I have replaced x and y as. Okay. Now, let us take another example. Let us take a curve, closed curve, which is a circle, is x y. I have circle of radius r, then I will write x y z coordinates for this circle as r cos theta, r sin theta, comma 0, where r is a constant and theta varies between 0 and 2 pi. Okay. So, this is the circle represented as a curve. Okay. So, in all this what you see is there is just one parameter that varies, the rest of the things are constant, the definition of those functions. The varying variable can be represented as psi or theta or x or y or z. Okay. So, basically what we find is a curve is a single parameter family of functions. A single parameter means that one of the parameters alone will vary to capture the various points on the curve. Okay. Now, how do you find the arc length of the curve? Say I have this curve, I want to find what is this arc length. Okay. Now, let us take 2 points and let us say there is a secant connecting these 2 points. Okay. Now, let us say this has coordinates x1, y1, z1, this has coordinates x2, y2, z2. Now, what is the relationship between x1 and x2? x1 and x2 would be x1 is f of x at psi 1, y1 is f of y at psi 1, z1 is the function f of z at psi 1, and x2 would be f of x at psi 1 plus delta psi. Similarly, y2 would be f of y psi 1 plus delta psi, z2 would be f of z psi 1 plus delta psi. So, now what is the distance, what is the length of the line? If this length were to be delta s would be square root of x1 minus x2 the whole square plus y1 minus y2 the whole square plus z1 minus z2 the whole square, which will be square root of f of x psi 1 minus f of x psi 1 plus delta psi whole square plus f of y psi 1 minus f of y psi 1 plus delta psi the whole square plus f of z psi 1 minus f of z psi 1 plus delta psi the whole square. Okay, that is delta s. Now what I want to do? I want to sum this delta s from psi 0 to psi 1, say this is psi 0 to psi n. I want to sum up all the arc lengths. Okay. So, basically now S would be summation this delta S1 say delta Si, okay, delta Si I equal to 1 to n. Okay. Now, in the limiting process I want to limit n to infinity, limit n tending to infinity. You can show that this will become basically square root of n tends to infinity. If n tends to infinity, delta psi would tend to 0 and hence this will become the definition of dou f x by dou psi the whole square plus dou f y by dou psi the whole square plus dou f z by dou psi the whole square into d psi integrated from psi 0 to psi n. Okay. So, basically now the arc length S is given by integral psi 0 to psi n square root of dou f x by dou psi the whole square plus dou f y by dou psi the whole square plus dou f z by dou psi the whole square into d psi. Okay. Now, what will it be for a straight line? Yes, for a straight line f of x is, I wrote it as x mx plus c comma z naught. So, it will be root of integral x 0 to x 1 1 plus m square plus 0 dx, or it will be root of 1 plus m square into x 1 minus x 0. Okay. Now, m is nothing but tan theta, this is x 1 minus x 0 by cos theta, since m is tan theta. So, this is nothing but the length of the member L, okay, length of the line L. Okay. Same thing if I use cos theta psi sin theta psi 0 plus c as the equation of the line, then this is going to be essentially S is going to be root of cos square theta plus sin square theta d psi integrated from psi 0 to psi n, which is psi n minus psi 0, which is nothing but the length of the member. Okay. So, basically there here the psi is represented as the arc length measured along the length of the member. Another representation that we had was, okay. So, another example that we looked at was a circle wherein S would be, now for circle you add r cos theta r sin theta 0 representing the circle, this will be integral 0 to 2 pi cos theta whole square 0 to 2 pi integral dou x by dou theta, that will be minus r sin theta whole square plus r cos theta whole square plus 0 d theta. This is nothing but r integral d theta 0 to 2 pi, that will be 2 pi r. This is the circumference of the circle. Okay. So, this is how you find the arc length of a curve. Okay. This is how you find the arc length of a curve. Okay.